We are going to look today at public access, public interest data sets and looking at why we care about that, why we felt the need to do some tooling and what the tooling helps people to do. It's a demo. But most importantly, what I want to press throughout all of this, if you have thoughts or if you're seeing things that trigger memories or trigger ideas or anything, all of this is driven at getting involved. I would love to work with more people on this. We'd love to get more opinions and grow the tooling and the standard and the use of commons data in Filecoin as efficiently and as best as we possibly can. So do think about getting involved and store up your questions for a Kumo space later on. So why are we here? Why do we care? It's important to sort of level set on what we think commons data is. We have a lot of names for them. We have public interest data sets, we have public goods data. Sometimes there's different words around the ecosystem for this stuff. But essentially what we're looking at is data which is genuinely for the common good, things that should be open and free. Personal issue of mine over the years has always been that it's such a shame we waste so much time and energy recreating things that we already had. Like if someone's gone to the effort of creating something, why don't we just sort of leave it there and then build off that and move along? And so all of these really interesting, useful data sets that are on Filecoin or could be on Filecoin, we want to make sure that they are actually delivering a public good benefit, that they're genuinely non-rivalrous, that they don't exclude people, that they are actually freely available. And this means many examples. Again, we could look back over the last 5 years of Filecoin and find many examples, but this is things like journalism, climate data, national libraries, there's geospatial data and things on there. All sorts of stuff which can be for the common good. And which is genuinely useful to a lot of people, not only now, but also in the future. Because I think one of the big things for why do we care about this in Filecoin is not just about sort of publishing stuff right now, but also making sure that no matter what changes along the way or what services come and go or how the political weather changes, that we can still access this, that we know that it's the right stuff, that we know it's not been modified or taken away or just sort of more reasonably just fallen through the cracks, because things have a habit of just losing funding at some point and then they disappear forever, and that's a huge shame. So we want to make sure that all of this commons good data, as much as we possibly can actually be preserved on Filecoin and actually be useful to people. So that brought us to the thought, and I work for FIDL, so we do a lot of work on sort of monitoring the incentives, looking at the Fill Plus programs, seeing how performance is going on sort of things like dataset retrievability and things like that. And one of the big hurdles we came across was actually being able to really reliably find and then retrieve and then use these data sets. Even if they're there, it's hard to find them. If you find them, it can be difficult to get downloads for all sorts of reasons. And even if you've got downloads, it's not necessarily very clear what you've now got in your hands. If it's just a raw car file or something, and you have to unpack it and you have to inspect it and things like that. And actually, this wasn't just an issue for us. There are all sorts of issues for the people onboarding and preparing and packing this stuff, as well as the folks who then want to use it, like we did. And also for longevity of these data sets, if we can just agree on one way of doing things, one way of packing things, one way of describing what's in the packed car files, and then find some place to actually advertise all of those data sets and know where they are. So really just trying to knock down hurdles and full disclosure, learning lessons from many past projects. There have been many efforts to do this. There are many dataset browsers. There have been directories and GitHub repositories and things in the past. So really trying to not just have yet another of these, but actually try to learn those lessons, talk to everybody, and come up now with a campfire that we can all sit around and actually prepare this data, put it up on Filecoin, and make it super discoverable and useful, and really show the true benefit of what decentralized long-term storage can give you. So we've done a thing which has gone quite well with our tooling and manifest specification. So it comes in three main parts, and in order here, they're kind of highly concrete to extremely abstract, going left to right. But we've got a manifest format specification because, as we say, one of the biggest issues with using open data sets at scale that we were encountering is just simply that they were all packaged and prepared and advertised differently. So it's not necessarily that anything was ever wrong. It's not necessarily even that one particular format or set of techniques was better or worse than any other, but it's just that if everything's different, it makes it very difficult for the users and people at scale to use and rely on Filecoin datasets because everything's a slightly different set of tools or a slightly different thought process or whatever. So coming up with an interoperable spec that you can post both inside your pieces, inside the car files, and also advertise outside of the network or adjacent to the network that says, here's all my stuff and here's what's in it and here's what you're getting if you download this data set in an interoperable way just really helps everybody. So we've got this spec, and we'd really like this spec to be something that evolves, and we want to evolve it with a community, but not really diverge too much. We don't want forking of interop specs because that's kind of against the point. But then alongside that, we've got some reference tooling. It's again very much based and built on the sort of best learning of the previous exploits of the community. So we've even got some Synapse SDK stuff in there. We've kind of jumped straight into that, and also using a lot of the robust stuff that comes from the IPFS community for car file packing and efficient packaging, efficient splitting, and so on. And most importantly, being compatible with those tools, because the last thing we want is to just introduce a yet another new way of doing things. So we need to make sure that we're compatible with things like Boost and Curio and Singularity on the data prep end. So the reference tooling is pretty complete, pretty comprehensive. We'd be glad if people use it, and we are working on integrating it with other tool sets. But if you wanted to fork that, if you want to make new versions, if you just want to pluck some code out of the middle and do your own thing, that's cool. We kind of welcome lots of innovation there. And then lastly, the data sets aren't necessarily very useful unless you can find them. And so, as I mentioned, we've got a lot of history of having partial repositories or small directories or explorers, but explorers that only explore certain data sets and so on. So we really want to inspire innovation and development in that space and make sure that once things are stored, that some way, somehow, they are discoverable, searchable, findable, that we can promote the best that Filecoin has to offer and is supporting. And so we've also got a repository and directory application. And this one, I think it's very unlikely that we'd end up sort of being the central keepers of such a thing, or indeed that there should be a central thing. I think there's a lot of innovation space for it. But we've done this for inspiration and to really spur innovation, because this does have to happen. And there's no better way of making things happen than do them. And so we also have that as a pretty nice start to advertising all these data sets and really showing, going right back to the left-hand side, how powerful it is to have this interoperable data prep right at the beginning, that you can then do a huge number of more powerful things more effectively and more efficiently at the retrieval and usage end afterwards. So just a quick note about the manifest, because this is the most sort of technical complete thing. It's really quite simple. It's JSON. We did have discussions and we did consider non-JSON alternatives, everything from the closed JSON LD to discussions about whether it should be CBOR or whether it should be something else. But JSON ended up being probably the best choice. We think it's the best choice. So it's a nice JSON descriptor. And for a given data set, so we don't have strong opinions about what that is, but anybody who is wanting to store data, maybe it's one experimental run, maybe it's 1 year's worth of voting ballots or something, They get to decide what their data set is. That's what ends up getting packed into a deal in the end via car files. And so for that entire data set, you have one big manifest that says, here's everything that's in it, and here are the pieces that it's in, so that you can go out and find those pieces. And here are all the subparts, so that if you only want to download a subpart, you can also find all of that. So we make a big manifest, and then we also pull out those contents information and shove them in the top of the car files that are actually uploaded, so that when you do download a piece, if either you kind of found it under a rock or you're not quite sure which one you wanted it for, you are able to very quickly check from the head element in there that you've actually got the correct piece and what is in there. So a little bit of redundancy, but we think it's useful redundancy going by the use cases and the sort of download type use cases that we had. Now we have a metadata template. So obviously, we like to auto-describe as much as we possibly can from the data set. We remember the whole aim of this is to make life really simple for data onboarders and for data users. So we don't want it to be super complicated. We try to do as much as we can automatically, but we do require the dataset owner to provide a little bit of metadata just to tell people what it is, what it's doing, and crucially things like the link where you can go and get more information, because they will know more about the data set than we ever could do as a sort of utility provider. And then beyond that, it's really simple. It's just 4 operations. You can pack, you can unpack, you can list, and you can verify. And these obviously in the deeper options, we come here for an example of the pack. The deeper operations are compatible with and use the same kind of language as the IPFS tools and car packing, and there's also some Storacher libraries in there, so highly compatible with the advanced features and the words that are used in there and the data types and formatting and things. They would all be very familiar to you, but what we want to present, and ideally what people will just use, is a very simple, straightforward pack or unpack, have a look or verify what's in there. And then the directory, and I don't need to talk over this slide because we've got a demo.
Okay, so all very straightforward. I have a copy of the uncensored library sitting here, and up in the parent directory I also have a metadata file with just a little bit of information about it that's been provided to fill in the standard. And then all I need to do, if I put in the help, you'll see there's lots of options, but it doesn't need to be this complicated. This is for sort of edge cases and so on. So all I'm going to do is output to here. I'm going to point it at the metadata file that we just looked at, and we're going to pack the whole thing. So hit the button and off it goes. So this is around about 2.8 gigabytes, nearly 5,000 files, as you can see. So on my machine here it takes about 3 minutes, but by the magic of television we are going to have it done right about now. Okay, and there it goes. And now what that's done is done a couple of things. It has written us a piece. This is only see 2.5 gigabytes, so it doesn't go over to multiple pieces, but we do cope with multiple pieces. And it's also written this this manifest, which if we just quickly have a look, includes some of the information that was provided by the user and also some important auto-generated information, including the contents, all of the bits and bobs, and all the pieces that it is stored in. So at the end of the preparation process, uploading the manifest to a repository means that we can start to actually explore these data sets. So in general, if you want to see what you're looking at, if you're interested in research, you can find researchy things. If you're interested in cats, you can probably find catty things as well. But what we're really interested in right now is the thing that we just did. So go over to the holding pen, which makes sure that you can't just spam horrible things onto the internet at will. We find this, we know what it is, we know it's good, so we're going to approve that, and then it appears immediately in the directory. And from there, we can have a look at what we've got here. So visit the project website. Of course, nobody knows Dataset better than the Dataset owner, so we can go there. We can also browse pieces. So obviously this hasn't been stored and sealed yet. We only just prepared the data. But once you have that stored and sealed, you'll be able to find that. You'll be able to choose an SP to download it from and get that data. But of course, if you're not quite sure yet, it is 2 gigabytes. Maybe this is good, maybe it's not good. We can also explore it. So have a look through the file structure, make sure it's the right one, make sure it's the right thing, or indeed just take a quick friendly look at the manifest itself so that we can be sure that we know actually how to use this thing. So is it the right version? Where did it come from? Do we know actually how to interpret the data inside? All of that stuff we can get before we go and commit to doing it. So so there we go. I mean, this is just an example. It's really there to inspire, because of course the business of if you go here, for example, the business of really getting inside and viewing data is a bit different to searching, is a bit different to directories. I think there's going to be many services and many different specialized offerings that do things like actually downloading things. And maybe that'll be easier with PDP perhaps than with big POREP deals. But the whole thing is that once we have interoperability and we have a standard manifest format that everybody can dance around, everybody can parse, everybody can look at, with standard references to kind of downloadable on-chain pieces and so on, what that enables us to do is to really double down on making data useful and not waste so much time on just trying to find it or trying to understand what it is.
And yeah, so just to really stress the point, this is a V1. The tooling is pretty good. The spec is very good. But the next steps are all up to us, and I hope in the intervening few weeks, and also in Buenos Aires, and indeed on Slack or anywhere else, we can start to evolve this stuff together to really make the most of the public goods data sets and the opportunities that we have in the sort of the whole of Filecoin to really make the most of that and push them forward. So we've had a lot of conversations on where to take it. Some suggestions that we didn't think were great for the MVP, but we might do later. Some things that just felt like a bit of a stretch to get done all in one go. But all of these things are up and open for discussion. So not just the dataset directory things or whatever. I think there's a lot of activity and growth to happen there, but also technical things. So we've taken a lot of care under the covers to make sure that it's compatible, as I mentioned, with things like Singularity, but that includes things like highly efficient in-memory comp parsing. It means that we support streaming. So if you've got a 2 gigabyte data set, you don't have to also have another 2 gigabytes of spare disk and another few gigabytes of RAM to process the whole thing. So we've gone to quite a lot of steps to make sure that it's really efficient and it's compatible with other tooling and it works for sort of the big data use cases. But there's lots of other things we could be doing as well, right? Some people have suggested not doing car files at all. I mean, that doesn't solve our use cases in sort of Filecoin Plus world, but we can certainly look at things that take us sort of a bridge to other IPFS use cases, but also things like Dazzle and Mazzle. There's a lot of innovation happening around the format and retrievability, and especially partials and block sizes and things like that that could be really interesting. So we're really interested in both kind of flashy use case, just make things happen, but we are also super receptive to highly technical changes, especially if they make kind of machine demands much lower and things like that. So please do come with both types of suggestion. So yeah, how can you get involved? I have a color scheme compliant QR code here, which we'll leave up for a second. If you want to go and visit the repo, so the tooling and the spec are in the repo, and we intend to version the specification itself also at this GitHub address, so it will be persistent and you'll be able to link to it from those JSON files. That also helps with things like auto parsing and whatever. So the spec and the tooling, both sitting there in that GitHub repo. And then yeah, lots of ways to get involved. I mean, proposing data sets for a couple of reasons. Again, we love to see data sets because we love use cases and we love to see Filecoin being used for what it's best used for. But also, I'm super interested in oddly shaped data sets, things with a million tiny files or things with one enormous file, and so on. All sorts of things like that are really interesting just to make sure it's robust and works for everybody. If you've already got a little bit of an operation or a home lab going, try it out. It's super simple and all the documentation's there, so you can just run it. And if it doesn't work for you, file an issue. Um, and if you are so minded, write some code, make a fork, make a suggestion, fix some things up. If anybody wants to integrate with some other data prep tooling, as I say, we're sort of walking down that road, but we would absolutely love to walk down that road with a few friends and make it happen as fast and as best as possible. So any of those things, yeah, please do get involved. And if we don't meet you in the GitHub space, I hope to meet you in the Buenos Aires space.